A new dawn for AI introducing A231. The world is on the cusp of a new era in artificial intelligence. We call it A231. This isn't just an upgrade, it's a fundamental shift in how we interact with machines. Imagine a future where computers understand us, not just our words, but our intentions. Imagine AI that can reason, create, and even feel. This is the promise of AI 231. AI 231 is more than just algorithms and data. It's a symphony of math and language working in perfect harmony. This powerful combination unlocks new levels of communication between humans and machines. We're no longer limited by the constraints of traditional programming. AI 231 allows us to speak the language of thought itself. The possibilities are as limitless as the universe. AI 231 has the potential to revolutionize everything from healthcare to transportation. It can help us solve the world's most pressing problems, from climate change to poverty. This is a future worth striving for. But with great power comes great responsibility. As we venture into this uncharted territory, we must proceed with caution and foresight. The future of AI is in our hands. Let's build it together wisely and ethically. The text describes a 5-stage encryption process with some interesting ideas, but it uses terminology in unconventional ways and lacks technical details for a definitive analysis. Here's a breakdown of what I can understand, along with some areas requiring clarification. The text mentions a 5-stage process, but it only provides details about the first 2 stages and the final stage. This stage likely involves some form of semantic encryption, where the meaning of the message influences the encryption. However, the text doesn't explain how semantics are translated into an encryption key. This stage supposedly covers the first encryption and alters the semantics of the letters. It's unclear how this is achieved. The final stage involves combining parallel lines to create a seal for the encryption. This is described as a semantic process, but it's not typical in cryptography to use semantics for creating seals, usually digital signatures. The text emphasizes the semantic aspect of the encryption, where the meaning of the message influences the encryption process. This is an unconventional approach in cryptography, which typically relies on mathematical operations. The image you sent appears to be a projector. While projectors can be used to display information, they don't directly relate to the concepts discussed in the text, which focus on a multi-layered encryption process. The text uses terms in non-standard ways. The meaning of semantic shoes in this context is unclear. It's difficult to understand what a village police form refers to in relation to encryption. Specific details about the semantic encryption process in stage 1. How the second stage alters the semantics of the encrypted data. The mechanism for creating a seal through combining parallel lines in stage 5. The role of crystallographic groups, mentioned previously, in this encryption process. The concept of semantic encryption is intriguing, but it requires a more rigorous definition within the established framework of cryptography. The provided details are insufficient to assess the effectiveness or security of this proposed method. For a more secure and well-understood approach to data encryption, consider exploring established cryptographic techniques like public key cryptography and symmetric cryptography. These methods offer proven security measures based on well-defined mathematical principles. The convergence of math and language is not just a theoretical concept, but a practical approach that is revolutionizing the field of artificial intelligence. At the heart of AI 231 lies a profound idea combining the precision of mathematics with the nuance of human language. This combination merges the logical with the emotional, the structured with the fluid, creating a more holistic approach to understanding and interacting with the world. For decades, AI has relied heavily on mathematical models. These models are powerful, but they often struggle to capture the complexities of the real world. They can process vast amounts of data and identify patterns, but they lack the ability to understand context, intent, and the subtleties of human communication. Human language, on the other hand, is messy and imprecise, yet it's how we understand and interact with the world around us. AI 231 bridges this gap by integrating the structured nature of math with the fluidity of language, creating a system that can navigate the intricacies of human communication. It uses mathematical expressions to represent the underlying logic of language. This means that the AI can break down sentences into their fundamental components, analyze their structure, and understand the relationships between different elements. Think of it like this. Math provides the skeleton and language adds the flesh and blood. This analogy helps us understand how the two elements work together to create a more complete and functional system. This allows AI 231 to process information more like humans do, understanding not just the words themselves, but the context and intent behind them. It can interpret nuances, detect emotions, and respond in a way that feels more natural and intuitive. This fusion of math and language opens up exciting new possibilities for AI. It enables machines to perform tasks that were previously thought to be the exclusive domain of humans, such as understanding complex instructions, engaging in meaningful conversations, and even creating art. It enables machines to understand and generate human-like text, making them capable of writing essays, articles, and even poetry. This capability is transforming industries such as journalism, content creation, and education. Translate languages with unprecedented accuracy, breaking down language barriers and facilitating global communication. This has profound implications for international business, diplomacy, and cultural exchange. And even write different kinds of creative content, from screenplays to novels. AI is becoming a valuable tool for writers, helping them to brainstorm ideas, develop plots, and refine their prose. The potential applications are truly mind-boggling. AI 231 is being used in fields as diverse as healthcare, finance, and entertainment, driving innovation and improving efficiency. But the true power of AI 231 lies in its ability to enhance human creativity and problem-solving. By providing tools that augment our natural abilities, it allows us to tackle challenges that were previously insurmountable. By providing a more intuitive and natural way to interact with machines, AI 231 empowers us to think in new ways and explore uncharted territories of knowledge and innovation. It is not just about making machines smarter, it's about making humans more capable, creative, and connected. Crystallizing thought. Visualizing AI's inner workings. In the ever-evolving world of artificial intelligence, understanding how these systems think and make decisions is crucial. The ability to visualize these processes can transform our interaction with AI, making it more transparent and comprehensible. One of the most remarkable aspects of AI 231 is its transparency. Unlike traditional AI systems that often operate in a shroud of mystery, AI 231 opens up its processes for us to see. This transparency is not just a technical feature, but a paradigm shift in how we perceive and interact with AI. Traditional AI models are often black boxes. We input data and they output results, but the journey in between remains hidden. This opacity can lead to mistrust and hesitation in relying on AI for critical decisions. We feed them data and they spit out results, but we don't always understand the reasoning behind their decisions. AI 231 changes that. By making its decision-making process visible, it allows us to see the why and how behind each conclusion it reaches. Using a technique called crystallographic charting, AI 231 transforms abstract data into visual representations. This method is akin to turning a complex mathematical equation into a beautiful, intricate diagram that anyone can understand. AI 231 allows us to visualize the inner workings of its thought processes. Imagine being able to see the gears turning inside a machine, each cog representing a piece of data or a step in the decision-making process. These charts resemble intricate crystal structures, with each node representing a concept or idea. The beauty of these visualizations lies in their ability to simplify complexity, making it easier for us to grasp how AI thinks. The connections between nodes illustrate the relationships between these concepts, revealing the logical pathways that AI 231 takes to reach its conclusions. This network of nodes and connections is like a map, guiding us through the AI's thought process. This visual representation is invaluable for understanding how AI 231 works and for identifying potential biases or errors in its reasoning. By seeing where the AI might go wrong, we can correct it and improve its accuracy. It also provides a powerful tool for debugging and improving AI models. Developers can use these visualizations to pinpoint weaknesses and optimize the AI's performance, ensuring it operates at its best. By visualizing the thought processes of AI, we can gain a deeper understanding of its strengths and limitations, paving the way for more robust and reliable AI systems. This knowledge is essential for developing AI that we can depend on in various applications, from healthcare to finance. Moreover, crystallographic charting can foster greater trust and collaboration between humans and AI. When we can see the inner workings of AI, it becomes less of a mysterious entity and more of a partner we can work with. When we can see how AI arrives at its conclusions, we're more likely to trust its judgments and work alongside it as a partner rather than just a tool. This partnership can lead to more innovative solutions and a future where humans and AI collaborate seamlessly. Professional summary of AI model for identifying contradictions in international linguistic logic. This AI model is designed to identify contradictions in international linguistic logic law. It is trained on a large data set of labeled examples and uses a sophisticated machine learning algorithm to identify the features of the text that are associated with contradictions. The model is then evaluated on a held-out test set to ensure that it is able to generalize to new data. The model has the potential to be a valuable tool for lawyers, judges, and other professionals who work with international law. It could help them to identify and resolve contradictions in international treaties, laws, and regulations. Benefits of the model. The model is able to identify contradictions in a variety of different types of text, including legal documents, treaties, and regulations. The model is able to take into account the context of the text, the meaning of the words, and the rules of international law, linguistics, and logic. The model is able to provide detailed explanations of the contradictions that it identifies. The model is scalable and efficient. It can be trained on large data sets of text, and it can be used to identify contradictions in real time. Potential applications. A tool to help lawyers identify contradictions in legal documents before they're filed in court. A tool to help judges identify contradictions in the law before they make a ruling. A tool to help researchers identify contradictions in international treaties and regulations. Additional thoughts. The proposed AI model has the potential to make a significant contribution to the field of international law. It's a powerful tool that can be used to improve the accuracy, consistency, and efficiency of legal work. Professional high-tech developers' language. The proposed AI model is a natural language processing (NLP) model that uses machine learning to identify contradictions in international linguistic logic law. It is trained on a large data set of labeled examples and uses a sophisticated algorithm to learn the features of the text that are associated with contradictions. The model is then evaluated on a held-out test set to ensure that it can generalize to new data. The model is implemented in Python using the TensorFlow library. It is scalable and efficient, and it can be used to identify contradictions in real time. The model has the potential to be used to develop a variety of applications, such as a tool to help lawyers identify contradictions in legal documents before they are filed in court, a tool to help judges identify contradictions in the law before they make a ruling, a tool to help researchers identify contradictions in international treaties and regulations. I believe that the proposed model has the potential to make a significant contribution to the field of international law. It is a powerful tool that can be used to improve the accuracy, consistency, and efficiency of legal work. Echoes of understanding sonographic images in AI 231. These images are not just visual representations, they are the heartbeat of AI 231, capturing the essence of its operations and the subtleties of its processes, complementing the visual clarity of crystallographic charts. AI 231 incorporates sonographic imaging to represent the flow and evolution of information within its systems. This dual approach allows us to see both the static and dynamic aspects of data, providing a richer, more nuanced understanding of how information is processed and transformed. Just as ultrasound technology uses sound waves to create images of internal structures, sonographic imaging in AI 231 employs a similar principle to depict the dynamic interplay of data and algorithms. This method enables us to visualize the invisible, to see the unseen movements and interactions that drive AI 231's decision-making processes. These sonographic images capture the echoes of AI 231's thought processes, revealing the patterns and nuances of its understanding. By examining these images, we can trace the pathways of thought, the connections made, and the conclusions drawn by the AI. By analyzing these patterns, we can gain insights into how AI 231 learns, adapts, and refines its knowledge over time. This continuous learning process is crucial for the AI to improve its performance and accuracy, adapting to new data and evolving scenarios. This is particularly useful for tasks involving natural language processing, where the meaning of words and phrases can change depending on context. Sonographic imaging helps us understand how AI-231 interprets language, how it discerns meaning, and how it adapts to different linguistic nuances. Sonographic imaging also provides a valuable tool for evaluating the performance of AI-231 models. By visualizing the internal processes, we can identify strengths and weaknesses, areas of efficiency, and points of improvement. By comparing the sonographic images of different models, we can identify areas where one model might outperform another or where a model might be struggling to grasp certain concepts. This comparative analysis is essential for refining and optimizing AI models. This allows us to fine-tune AI-231 models for optimal performance and accuracy. By understanding the intricacies of each model's operation, we can make targeted adjustments that enhance their capabilities and ensure they perform at their best. The combination of crystallographic charts and sonographic images provides a comprehensive and multifaceted view into the inner workings of AI-231. This holistic perspective is invaluable for researchers and developers, offering a deeper understanding of the AI's functionality and potential. This unprecedented level of transparency is crucial for building trust, fostering collaboration, and ensuring the responsible development of AI technologies. By making the inner workings of AI-231 visible and understandable, we pave the way for more ethical and effective AI systems, promoting a future where technology serves humanity with greater reliability and accountability.